Hello and welcome to Algebra 2 Lesson 47. In this video, we're going to learn about solving polynomial equations by factoring. So in some cases, polynomial equations can be solved using factoring. This technique revolves around using the zero factor property. Let me highlight that, this zero factor property. Now, your textbook might refer to this as the zero product property, but either way, whether you know it as the zero factor property or the zero product property, it's important for you to understand what it means. So here's an explanation of the zero factor, or again, the zero product property. Let me highlight this. You have if A times B equals 0. So let's stop for a second. A is just some unknown, B is some unknown. So this could be X times Y, it could be Z times Q. It could be presented in any different way. Two unknowns are multiplied together and the result is 0. If we have that, then one of the following scenarios has to be true based on the fact that if I multiply something by 0, I get 0. So it could be that A is 0 and B is not 0. So in other words, 0 times something that's not 0 would give me 0. It could be that B is equal to 0 and A is not 0. So something that's not 0 times 0 would give me 0. Or the third and final possibility could be that A and B are both equal to 0. 0 times 0 would also give me 0. So this is very important to understand. And when we start solving these equations using this property, it's not going to look like this. It's going to look slightly different. And I'm going to refer back to this zero factor property. And you go, oh, yeah, that makes sense now. Okay. But it's very important that you understand this conceptually. That way, when we start working through the exercises, you understand what's going on. All right, so the focus for today is going to be to solve quadratic equations by factoring. We did this back in Algebra 1, and then most of you will recall that some of these we couldn't factor. And when we had something that we couldn't factor, we learned later on in Algebra 1, we could use something known as completing the square, or we also can use the quadratic formula. So a quadratic equation is one where the highest power is 2. So in other words, if I see something like ax squared plus bx plus c equals 0, you look at your exponents. This one's a 2. This one's obviously a 1. And so the highest exponent is a 2. So this is a quadratic equation. Now with your quadratic equation, you have a as the coefficient for the squared variable, b is the coefficient for the variable raised to the first power, and c is the constant. A, b, and c can be any real number, with the one exception that a is not allowed to be 0, because you obviously wouldn't have a quadratic equation anymore. If I had 0 times x squared, that's just 0. And in that case, I have bx plus c equals 0. Okay, that would be a linear equation now. So let's talk a little bit about the steps that we would use to solve a quadratic equation by factoring. Now, if you get something that's more advanced than a quadratic equation and it's factorable, you're basically going to use the same steps. You might see something with the highest power being a 3 or 4 or 6. And there might be some tricks that you can use. You might be able to factor using substitution. You might be able to factor using grouping. There's all kinds of scenarios where this will be beneficial for you. So solving a quadratic equation by factoring. The first thing you want to do is write the equation in standard form. So standard form we've talked about a lot. So the left side over here, we have ax squared plus bx plus c. And if I was writing a polynomial in standard form, we know we want it in decreasing order of powers. So I would start with the highest power, which is a 2. Then I would go to the next highest power, which in this case is a 1. Then I would go to kind of the next highest power, which we have a constant, so we could say that variable is raised to the power of 0. So you'll notice that this is set equal to 0. And this is so we can use our zero factor property. We want this to be 0. All right, so the next step is to factor the left side. You've got a trinomial on the left side. You've got 0 on the right. So you factor the left side. That's going to put it into the product of two binomials. Then we're going to use the zero product property and set each factor with a variable equal to 0. And the reason we say with a variable, sometimes you can pull something else out, okay, before you start factoring, and you don't need to set that equal to 0 because that would be irrelevant. All right, the last thing is obvious. You just want to solve the equation and check. All right, so let's get started with the first example. So we have x squared minus 12x equals negative 36. So the very first thing I want to do is put this in standard form. So all I need to do is add 36 to both sides of the equation. So I would have x squared minus 12x plus 36 is equal to negative 36 plus 36 is 0. So the left side, if you look at it, this is a trinomial in standard form. I've got x squared, x to the first power, and I've got my constant. Okay, so that's what I want. On the right side, I have a 0. So what I want to do now is I want to factor this left side into the product of two binomials. Very easy to do. I know that I have x squared here, and this is a 1 as the coefficient for x squared. So this would be x, and this would be x. And I simply need to find two integers whose sum is negative 12 and whose product is 36. Well, I know I'm looking for a negative and another negative. Negative plus negative is negative. Negative times negative is positive. Okay, so let's just think about factors of 36. I've got 1 and 36. I've got 2 and 18. I've got 3 and 12. I've got 4 and 9. I've got 6 and 6. Now think about 6 and 6. 6 plus 6 gives me 12. So I just need to work out the signs. Remember, we already figured out it's a negative and a negative. So negative 6 plus negative 6 would give me negative 12. Negative 6 times negative 6 would give me positive 36. So x minus 6, that quantity, times x minus 6. Now, you'll notice that essentially we could have found this by using our special factoring. This is a perfect square, x squared, and 36 is a perfect square. And remember how to check the middle term. You think about, is this right here, this 12x, 2 times x times 6? Well, yeah, 2 times 6x is 12x. So we know this would have factored into the quantity x minus 6 squared. Now, in this particular case, because we have the same thing twice, I don't need to set each one equal to 0. I only need to say, hey, x minus 6 equals 0. What's the solution for that? Just drop the parentheses and solve x minus 6 equals 0. I add 6 to both sides of the equation, and I get that x is equal to 6. Now, let me stop and explain what I did. If we consider the zero factor property, remember, this is multiplication here. This is multiplication. So if the quantity x minus 6 is multiplied by the quantity x minus 6, well, one of these, and it happens to be the same thing, has to be 0. So if I can make this equal to 0, then 0 times whatever this is, it doesn't matter that it's the same thing if it was something different. If it's multiplied by this, it would give me 0. So in other words, if I plugged in a 6 here, 6 minus 6 would be 0. 0 times this, whatever it would be, and I know it's the same thing in this case, would give me 0. So that's how the zero product property, or zero factor property, however you want to say it, allows us to solve these equations when they're able to be factored. So if you wanted to check this, there's only one solution in this case. We'd plug in a 6 everywhere there's an x. So you'd have 6 squared, which is 36, minus 12 times 6, which is 72, and this should equal negative 36, and it does. 36 minus 72 is negative 36, so you get negative 36 equals negative 36. So this checks out. All right, let's take a look at one that's a little bit more challenging. So we have 7x squared plus 84 is equal to negative 7x squared minus 77x. So again, I want to put this in standard form. So I'm going to take everything and just move it to the left. The right should be 0. So I'm going to add 7x squared to both sides of the equation. And I'm going to add 77x to both sides of the equation. So this is going to cancel and become 0. So on the left side, I'm going to have 7x squared plus 7x squared, which is 14x squared. Then plus 77x. Then finally plus 84. Remember, the right side is 0, so this equals 0. Don't forget the equals 0. It's very important that you put equals 0. I see a lot of students forget to put this. They factor it, and then they've lost their way. They don't know what to do next. All right, so I want to factor this. Now, this is the harder scenario where the coefficient here is not a 1. So again, you can use reverse FOIL. You can use factoring by grouping. You can basically do whatever you want to do. It's just something that's going to work for you. Now, the first thing you should notice here is that you could pull a 7 out. So if I pull out a 7, this would be 2x squared plus 11x plus 12 inside the parentheses. This is equal to 0. So keep my 7 outside, and I want to factor this. I'm going to use grouping because it's just a little bit easier for me to do. So what I want to do is find two integers whose product is 2 times 12, or 24. So I want the product to be 24. So product is 24. The sum is this middle coefficient of 11. So you think about 24, and right away you think about 3 and 8, right? 3 plus 8 is 11. 3 times 8 is 24. So I could write that middle term. We'll have 2x squared. We'll put plus 8x plus 3x plus 12. Again, for those of you who are unfamiliar with this process, all I'm doing is I'm rewriting the middle term using those two integers that I found. So instead of 11x, I've expanded this to 8x plus 3x. 8x plus 3x is 11x, so it's legal. So let me put equals 0. Now I'm going to factor inside the parentheses using grouping. So this is super easy. We have 7 times. From the first group, I'd pull out a 2x. What would be left is x plus 4, then plus. From the second group, I'd pull out a 3. What would be left is x plus 4. So you can see you have this common binomial factor here of x plus 4. So I can factor that out. I would have 7 times the quantity, x plus 4. Then times the quantity, you'd have 2x plus 3. Now remember, this equals 0. Okay, so let's scroll down and get some room going. Now, I have 3 factors here. 7 is multiplied by the quantity x plus 4, which is multiplied by the quantity 2x plus 3. So 3 factors. This is a factor. So is this. So is this. Now, 7 does not have a variable involved. Do I need to set it equal to 0? No. I'm not going to waste my time. I'm only going to set a factor with a variable equal to 0. So I'm going to take this quantity, x plus 4, and set it equal to 0. So x plus 4 could be equal to 0, or, okay, we'll use this connective word or, 2x plus 3 could be equal to 0. So it could be true that this equals 0 or this equals 0. Those are our two scenarios. Because remember, if a times b equals 0, then either a is 0, b is 0, or they're both 0. Okay, so that's what we're just doing here. It's just a little bit more complex. All right, so to solve the first one, I just subtract 4 away from each side, and I get x is equal to negative 4. For the second one, I subtract 3 away from each side. This cancels. I get 2x is equal to negative 3. I divide both sides by 2, and we end up with x is equal to negative 3 halves. So in solution set notation, remember we'll put some curly braces. Let's list negative 4, comma, negative 3 halves. So those are two solutions. And that's it. We're done. If you want to pause the video and check, I would welcome you to do that. I've already checked this, so I know it works out. And in the interest of time, I'm not going to check anymore. But all you would need to do is just plug in a negative 4 for every x in the original equation. You'll verify that the left and the right side are equal. Then you'll plug in a negative 3 halves and for each x in the original equation. And again, you'll verify that the left and the right side are equal. All right, let's take a look at another one. So we have 25x squared minus 16x plus 3. And this is equal to negative x plus 1. So again, move everything over to the left. So I'm going to add x to both sides of the equation. And I'm going to subtract 1 away from each side of the equation. So the right side has canceled, and it is now 0. On the left side, I still have my 25x squared. And then negative 16x plus x, or you could say plus 1x, is negative 15x. And then 3 minus 1 is 2, so plus 2. All right, so now this equals 0. Don't forget that. And the simple fact is there's nothing I can pull out before I start. This is divisible by 5. This is divisible by 5 and 3. This is a 2. It's prime, so it's only divisible by 2 and 1. So if I think about what I'm going to do, I'm just going to factor this using grouping. So we want to find two integers whose product is 25 times 2, or 50. So the product is 50. And then the sum is negative 15, that middle coefficient. So we think about this. We know that it's going to be a negative and another negative. So go through the factors of 50. Right away, I think about 10 and 5. Negative 10 and negative 5 would work, right? Negative 10 plus negative 5 is negative 15. Negative 10 times negative 5 is positive 50. So again, I'm going to use that to rewrite this middle term. I'm going to have 25x squared minus 5x minus 10x plus 2, and this equals 0. So now that I have a 4-term polynomial, I'm going to just factor using grouping. So from the first group, I could pull out a 5x. That would leave me with 5x minus 1. From the second group, because I want to match the signs, I'm going to pull out a negative, and I'm going to be pulling out a negative 2. So minus 2 here, and then we'll have 5x minus 1. So we see we have a common binomial factor of this 5x minus 1, and we're going to pull that out. So I'll set this equal to 0. We'll pull that out. We'll have 5x minus 1, that quantity, multiplied by 5x minus 2, that quantity. This equals 0. All right, so again, I have two factors here. This is multiplication. So this times this gives me 0. So it must be true that 5x minus 1 equals 0, or 5x minus 2 equals 0. So we just need to solve each equation so we can get our solution here. So what we want to do, let's just add 1 to both sides. That'll cancel. You'll have 5x is equal to 1. Divide both sides by 5, and you'll get x is equal to 1/5. Over here, if I add 2 to both sides of the equation, that'll cancel. You'll have 5x is equal to 2. Divide both sides by 5, and you'll get x is equal to 2/5. So in solution set notation, we'll say inside of curly braces, we have 1/5, comma 2/5. So those are our two solutions. X equals 1/5 or x equals 2/5. Again, you can pause the video, check each solution, and verify that we got the correct answer. All right, for the last one we're going to look at, we have 8x cubed plus 22x squared plus 14x equals 0. So you might jump out and say, whoa, that's not a quadratic equation. When we can factor something like we will be able to here, you're going to end up being able to get the solution that way versus using some other method. So for 8x cubed plus 22x squared plus 14x equals 0, on the left side, it's already in standard form. The first thing you should notice is that there's a common factor of x, and there's also a common factor of 2. So I could pull out a 2x, and what would be left is 4x squared plus 11x plus 7, and this is equal to 0. Now inside the parentheses, we have a quadratic equation. So again, that's something that's familiar to us. So we have our 2x that just stays out in front. And I want to just factor the inside. So if I think about two integers whose product would be what? 4 times 7 is 28. So we think about a product of 28 and a sum of 11. Well, 4 and 7 give me that criteria. 4 plus 7 is 11. 4 times 7 is 28. So again, use that to rewrite that middle term there. So I would have 4x squared, then plus, we'll do 4x, then plus 7x, then plus 7. Okay, and this equals 0. All right, so I'm going to have my 2x here. From the first group, I can pull out a 4x. Then inside, I would have x plus 1. From the second group, I can pull out a 7. Then inside, I'd have x plus 1. So you have your common binomial factor. Let me just kind of scroll down a little bit. You have your common binomial factor of x plus 1, that quantity. And we can factor that out. So I'm going to have my 2x out in front. I'll have that quantity x plus 1. And then what's left? We'll have 4x plus 7. Now this equals 0. So now I have three factors here with a variable. 2x is multiplied by the quantity x plus 1, which is multiplied by the quantity 4x plus 7. So I've got to set each one equal to 0. Again, let me label this so it's crystal clear. This is a factor, this is a factor, and this is a factor. Just like if I had a times b times c equals 0, it's got to be true that a equals 0, or b equals 0, or c equals 0, or it could actually be, in this case, because we have 3 of them, any 2 of them equal 0 and the other one doesn't, or all 3 of them equal 0. Okay, so lots of possibilities. But the point is here that each one of these has to be set equal to 0 because it's a possible solution for us. So we would say 2x is equal to 0, or x plus 1 is equal to 0, or 4x plus 7 is equal to 0. So let's solve these three equations. All right, 2x equals 0 is very simple. You divide both sides by 2, you get x equals 0. Then for this one, x plus 1 equals 0, we subtract 1 away from each side. We get x is equal to negative 1. Then for 4x plus 7 equals 0, we subtract 7 away from each side. We get 4x is equal to negative 7. We divide both sides by 4, and we get x is equal to negative 7/4. So I'll put my or kind of like that. So we get x equals 0, or x equals negative 1, or x equals negative 7/4. So in a solution set notation, we put negative 7/4, comma negative 1, comma 0. So those are your three solutions. Now again, if you want to check this, go back to the original equation. You're going to plug in a negative 7/4 for x, then plug in a negative 1 for x, then plug in a 0 for x. In each case, you're going to verify that the left and the right side are equal.